So in this video we're going to be looking at continuous random variables. With continuous random variables, things such as time, length, weight, the associated probabilities will also be continuous. We define them using what's called a probability density function, or from here on in, a PDF. Usually we give this PDF the notation f of x to define what the function is going to be. Now, some properties of this function: it's always greater than 0, you can't have a negative probability. And also, if you integrate the function within its domain, the answer is always 1. The total probability is always equal to 1. If you wanted to find the probability of something that lies within an interval, so here between a and b, that notation with square brackets being inclusive for a and b, we integrate the function f of x between a and b, and the answer would give us our associated probability. We also have to be able to work out the expectation and variance of a probability density function. And that's the case of just using some formulas. So the first one, to find the expectation within its domain, you integrate x times f of x dx. And for the variance within its domain, you do x squared f of x dx minus the expectation squared. Very similar to when we did it for discrete random variables. So here's a question. Have a read of the question. Typical sort of thing which we expected to be able to do. So our process for this one. First of all, we know that the total of the probabilities when I integrate between the two limits, so in this case 0 and 4, must equal 1. So that's what we're going to do. We're going to integrate it, still keeping k into this. Substitute in our limits. And then we can rearrange to work out what k is. Now notice what I've done here is I've actually taken k out because it's a constant as a common factor of everything. I just often find it a little bit easier to do that. You don't have to. There's not a rule that says that's the most important thing, but that's what I tend to do. Now I know what k is, I can now use it for the second part of the question, when we've got to find the probability that there was less than 2 hours of sunshine during that given time interval. So in other words, the probability that x is less than 2. So here we're going to integrate between 0 and 2, and we're going to integrate our function. Again, I've taken my 3 over 128 as a common factor. Values go into square brackets, substitute in, and using my calculator, I can work out what the final answer is going to be. So here we have a second example. This time you'll notice that the probability density function f of x has been split up into two distinct parts, between 0 and 4 and between 4 and 8. But we proceed with it the same way as previously. So we're going to integrate each part separately within its given limits, and we know the total must equal 1. So our usual rules of integration apply here. We integrate each part, put it into square brackets, put our respective limits into it, substitute our limits into each expression, and we'll end up with an equation in terms of k. Now, there are no real shortcuts for this, just take your time with it. Show each step of the working. And we find that k is equal to 1 over 16. So now obviously we can use that for the future bits of the question. For the second part of the question, we're going to be asked to sketch the graph of y equals f of x. Using our knowledge of straight line graphs, we know they're straight lines because there's no quadratics or cubics or any other functions of x. It's just two linear lines, one between 0 and 4, one between 4 and 8. And the common point is when x equals 4. So what we know that we can do is we can simply draw out our graph like this, and we know that the highest point is at 4k, and if k is 1/16, 4/16 is a quarter. For part 3, we're asked to find the probability that between 3 and 6 hours of working time is spent. Now you'll notice this was going to incorporate time from both parts of our probability density function. So we integrate between 3 and 4 for the first part of the probability density function, and between 4 and 6 for the second part. Usual methods of integration will apply here. So exactly as previously done, into square brackets, put your limits on it, substitute into your limits into each expression that we've got, and then work out what the final answer is going to be. And so we get, using our calculator, type the last bit on the calculator, and we get our final answer of 19/32. We also have to be able to calculate the median and the mode from a continuous random variable. So the median occurs at the value of m for which the integral between the lower limit and m, or between m and the higher limit of each of the probability density functions, equals 0.5, the halfway point. In other words, the probability that x is less than m or the probability that x is greater than m is equal to 0.5. The mode, now if x is a random variable with a probability density function of f of x, then the mode is the value for which there is the highest value we can get. So it's where f dash of x, the differential of f of x, is equal to 0. So here's an example. First one, same as previously, we've got to find the value of k. So we're going to integrate our function between the limits that are given. So this is between 0 and 1. You might find it easiest to expand out the brackets. And notice again, I've taken k out of my integral because it's a constant. And each time I know that the integral is going to equal 1. So therefore we find that k is equal to 4. Now we said the mode, that's going to occur at a maximum point. So start off with the function, and we've got k is 4 this time. Differentiate it. And to find the maximum point, we know that f dash of x has to equal 0. So we find that x is going to equal 1 over the square root of 3. Now we're taking the positive value because our domain was between 0 and 1. We need to justify this as a maximum, so if we do a second derivative, and we substitute our value of x into it, so x is, remember, it's 1 over the square root of 3, or the square root of 1/3, and we know that's f double dash of x is less than 0, so therefore it is a maximum. To find the median, we're going to integrate between the lower limit, 0, and m, our function, and we know the answer has to be 0.5, or a half. So again, as before, you might find it easiest to expand out your brackets first. integrate, substitute values for m into it. Multiply everything through by 2 to get rid of the fraction. So 4m squared minus 2m to the 4 equals 1. Rearranging it to make the m to the 4s positive. And then, using my calculator, I'm going to solve it to find what m is going to be. My calculator does give other values, but the only one that was in the relevant domain was m equals 0.541.